Good morning, everybody, and thank you for joining our session, a lecture session on how labels and sleeves can support recycling. This initiative has been set up together with Suez. Vincent Moy will join us on stage in a minute. He is the head of Suez Circpac, explaining about the recycling solutions in Europe for I say the design for bottles and packaging. So there are different solutions out there, and Vincent will touch upon the do's and don'ts in recycling for the design of the packaging. Later on, I will explain something about solutions that Avery Dennison bring to you as customers and persons in the industry that can support sustainability and help us recycle for the future and make sure that the resins that are out there stay in a circular economy and can be used over and over again. So for now, I would like to introduce Vincent Moy to the stage.
Thank you.
Vincent,
So good morning to you all. Thank you. Let me start with some questions. How many of you have ever been buying film material, label material, or sleeve material, or have been selling it? Yeah? How many of you have said, when asked whether it's recyclable or not, said, yes, it's recyclable? Okay, I will tell you today that in practice, it will not be recycled. Yeah? So you might be from this business, or brand owner, retailer, but you're typically working on the top level side of the circle. Production, packaging, distribution, and finally consumer usage. And this is where we actually pick up. So this is a picture in our sorting installation in Rotterdam, where we gather all kinds of household packaging material. Looking like this, not as neat as it was in the shelf, but it's still a raw material. And we try to sort it as good as possible and then ship it to recyclers who actually will use most of the material that they get shipped and try to make it into new granulate. So typically we're working on the bottom end of the circular economy. And you can imagine that we need to work together, need to have full understanding of what's going on so we can actually align those two and really make it circular. When we look at packaging, to me there has always been 4 essential ones, and now we've got a 5th one. So you need to protect your goods, you need to preserve it, especially for food materials. It needs to communicate. You need to be able to promote your material. And it needs to be cheap. But now there's a 5th P, and that's the post-usage. What will happen in the afterlife? So it needs to be recycled. And when we look at recycling, it's not theoretical recycling somewhere in a laboratorium. It needs to be done in practice and at scale before we consider it to be recyclable. So we've actually set up 4 criteria, meaning that the material needs to be collected, so some sort of collection system needs to be in place. We should be able to sort it correctly and send it to a certain type of material fraction. And this material fraction, the big bales of PET or PP, then go to we always call it a recycler, but they're actually a reprocessor. Yeah? And there needs to be a market for the end material. Only when these 4 criteria have been met, we consider it recyclable material. I started with the question, who says that their material is actually recyclable? And you're basically talking about the 3rd one. Yes, a lot of materials can be reprocessed. I can be reprocessed as well somewhere at the end of my life, but it's all possible. But is there a collection system? Can it be sorted, and is there an application for it? Let's have a short look at our sorting installation in Rotterdam to show you some of the questions we have in the sorting.
Rotterdam is home to Europe's most advanced sorting plant. Here, Suez sorts so-called PMD waste from Dutch households to prepare it for recycling. More than 200,000 kilos every day. That's about 40 truckloads. PMD waste consists of plastic packaging material like plastic bags, foil and bottles. Metal packaging material including tin cans, metal lids and aluminium containers. And drink cartons for beverages like milk, yogurt and fruit juice. The first thing we do is remove large pieces of plastic foil and any other unwanted materials. Then the waste bags are opened. The contents are tipped out onto a conveyor belt. This takes the waste through all kinds of sorting machines. A drum sieve with different sized holes sorts the waste according to size. Lightweight materials, such as foil, are suctioned out onto a different conveyor belt. At the next stop, we use a magnetic belt to remove the steel cans. The residue passes on to an infrared scanner that can identify drink cartons. These cartons are blown out using powerful air jets. An electric current generates magnetic fields. This makes the aluminium magnetic. Then, by the effect of opposite poles, the aluminium is shot out. Now all that's left is the plastic packaging. It's time to give the whole lot a bit of a shake. Three-dimensional shapes move differently to flat plastic. This makes it easy for us to separate them. Infrared separators filter different types of plastics at the next stops. Polyethylene terephthalate, or PET, polyethylene and polypropylene. The residual waste passes infrared separators once again to ensure that no recyclable materials are left. Human interaction is only present at the very end. After a final inspection, the material is stored in bunkers according to material type. Each bunker is automatically emptied as soon as it is full. The sorted material is compressed into bales. This ensures efficient stacking and transporting. The material is taken to the warehouse, ready for transport to the relevant recycling company. That's how we innovatively process more than 100 kilotons of packaging waste every year into raw materials as a resource for new products. This way, we close the chain and protect our natural resources.
So, that was our sorting installation in Rotterdam. And it's quite typical for modern sorting installations throughout Europe and throughout the world. The technologies that are being used there are quite similar around the world. But you can imagine if you have such a large diversity of materials coming in, that you have to really make design choices which can help the sortability of these fractions. There are some issues or possible issues with recycling. So far we have seen that design has been on, of course, a preservation of the packaging, but also a lot on marketing and communication. And cost reduction. Cost is very essential. But this has led to incorrect sorting due to too large sleeves and labels. And with that, low recyclability because wrong combinations of materials have been used. It can actually downgrade the quality of the recycled granulate. And with that, we actually are stimulating the need for virgin polymers. It also has led to an increase in EPR fees Because if the outcome of this entire sorting and recycling is more positive and the yield is better, then the EPR fees will actually go down. Just to give you an idea of one of the technologies that is used very often in a sorting plant, that's NIR, near infrared. So we have a scanning device hanging over the conveyor belt, and it's actually taking a picture, looking for the fingerprint of the material underneath. You could say, okay, this one is detecting PET bottles, for instance. As soon as he's seen PET, identified that there's a PET bottle underneath, he gives a signal to the air jets, will actually shoot out at the right point in time and shoot the bottle over the threshold, separating the PET from other materials. Yeah? Now here we see a picture that we can see, and this is sort of what the installation sees. So typically we have a Coca-Cola bottle, which is PET. Yeah, you can see it here. It's green on both sides, but it has a probably LDPE sleeve around it and a PE cap. Yeah, the PE, you can see it over here. As you can see, it doesn't say LDPE in the middle. It just basically says, I don't know. Because it's actually looking through the material at 100 micron, looking both at the sleeve and at the PET bottle. So it's getting mixed signals. So it's not able to identify what this material is. Luckily, we have been able to teach the installation that if you see PET on both sides, shoot it out as PET. Then you're 99% of the times you're correct. But you can imagine that if you have a full body sleeve or a very large etiquette, it will be much more difficult to separate those. We've set up some design guidelines, designed for recycling, and these are pretty much in line with everything that's available from Plastic Recyclers Europe, Recyclas, all the local EPR systems. And we've set them up for all these different materials. And we've said there are 3 types of materials in these packaging. There's the recyclable matter, which is actually perfectly fine. It can be recycled, no problem. Then we have the non-recyclable materials, which actually do not hinder the recycling, but will not be recycled. And then we have the conflicting materials, which actually, if they are in there, they will also make sure that the green parts will not be recycled, because they cause issues in the recycling process. And it looks like this. It's totally unreadable, I can imagine. I will get in some more details. But if you want to, you can leave your card later and we will send this one in PDF for all these materials. But it's actually looking at all different types of things. So it's main material, barriers, additives, closure systems, labels, sleeves, adhesives and inks. So for all these matters, we have information there. One of the main challenges is the size of the label and the sleeve. I showed you the picture of the NIR scanner. With a full body sleeve or a too large label, it will be impossible to identify the material underneath. And I've had some very nice designs say, yeah, but the coverage of my print or of my label is actually only 40%. Yeah, but if you look at it from a flat perspective, where the picture is taken, it's actually 70%. Okay, so you also need to consider the way it's being scanned. On adhesives, they will not be recycled. So we see a lot of statements these days about 100% recyclable. Even Coca-Cola company claims their aluminum cans are 100% recyclable. It's just not true. There's a plastic liner in there which will not be recycled. There's ink on the outside that will not be recycled. So please be careful with all the things you pledge to the market, because 100% recycling is not possible. And adhesives is one of them. There are some things that you need to consider when you use adhesives. They should be soluble in the washing process of the recycler, hot melts are okay and pressure-sensitive labels are okay for PET. What we don't want is non-soluble adhesives, yeah, which are not soluble in water or alkaline. For PP and PE, it's a bit different. There we only have water-soluble adhesives, which are okay, and in ambient conditions. So basically all the rest will cause issues somewhere in the recycling process. Inks also will not be recycled. They will be hopefully washed away with washing water, but generally never recycled. If you use standard inks, you're pretty much okay. Inks is not the biggest issue, but make sure that they don't bleed and are not toxic or hazardous. There's an EPA exclusion list. If they're on there, don't use them. Yeah? Labels and sleeves. Unfortunately, they will not be recycled. Maybe 1% will. If there is some recycling, it will be downcycling, but I will explain that a bit later. Typically, when we sort bottles, and if we bring a shampoo bottle to a PP recycler or PE recycler, they will start shredding the material. They start washing it. Hopefully the glue, the adhesive will let go. And then they start drying all these small particles and they put it through a zigzag or elutriator, which is basically you have material coming in, a mix of all small particles, and airflow is coming up. And this airflow is just hard enough to shoot out all the light particles. So all the sleeve and label material will be blown out, where the rigid material of the bottle will actually fall down. So this is how they typically already take care of over 95% separation. And all these materials that are blown out will go to incineration. If you're lucky, in some other countries it should be landfill, because if they don't have incineration, there's no alternative than landfill. So, which are okay to use with PET? Paper labels without fiber loss. It's quite essential that there's no fiber loss during the washing process. PE, PP, OPP, all with a density of less than 1, that could be okay. And please don't use materials with fiber loss or paper with fiber loss. Density over 1, because one of the steps in the PET recycling is a sink float. You start shredding the material, washing it, and at the same time, all the polyolefins and lightweight material will float, and the PET will sink. They're looking for the PET in this case, so everything that floats is okay, they will discard it. Yeah? PVC, all the chlorinated materials, PVDC, stuff like that, very unwanted. Polystyrene, but also biodegradable plastics, because they might cause issues in the PET recycling. If there's still a particle in there, then you will have some problems. And don't use foamed materials. For PE and PP, this is somewhat different, but the general idea is that there we are looking for the material that actually is floating. So if you want to remove sleeves and labels, they should sink. Still, PLA and other biodegradable plastics, please don't use them. How green they may sound, they will not be recycled and they actually might cause problems. For glass and metals, no problem. We will not recycle them. But it will not be a problem to have them on there. It doesn't matter what kind of material you use for that. What we've seen in the last year is that some EPR systems, so extended producer responsibility systems, they are now integrating some eco fees, some incentive to create recyclable packaging. And when you look in the Netherlands, the Dutch EPR system provides a 40% discount on plastic bottles, which are actually considered recyclable. And they've set up some rules in there also for the labels and sleeves. So if you have a PP or PE packaging, the label or sleeve should be the same material. No paper. PET packaging, no PET labels, because typically there you use GPET with the glycol in it, which causes yellowing effects and other issues in the recycling. But PP and PE or paper are okay. And again, some size remarks there. Sometimes you see the 70%, sometimes you see 50%. From our own experience and the big data we've gathered on everything we have sorted, we know that it's not that absolute. So if you're close to this 50%, it's already wise to have it checked by us whether it's sorted correctly or not. So if we want to close the circle, close the loop, then we actually have to work together. And for me, it started with understanding the plastic or the packaging industry. But the other way around, it's about understanding recycling and sorting. There are alternatives available. You can also reconsider the requirements of your packaging. Do you always need 16 months shelf life? Is it really necessary for all regions? Or can you also make some distinction in there? Integrated true cost or eco fees, the EPR fees in your calculations. Now we often see that this is totally different organization within a company, a different department. And with that, I think we can make some big progress. At the same time, the recycling industry is moving forward in chemical recycling, image recognition and watermarking, and much more robotization and artificial intelligence. I think that was my last slide. Yeah. So we have a couple of services that we can offer. Please, if you are interested in design guidelines, leave your, just put your card over here, and I'll make sure that you will get it by email. And then I think Jenny, and we have some time for questions.
Switch on the microphone
After.
again.
Sorry.
Thank you very much, Vincent. Very, very much appreciated. Yeah. So based on the guidelines of SUEZ and other institutes, Avery Dennison has come up with a solution for PET bottles. And it's called Clean Flake. You might have heard of it before, as we had it on the Labelexpo also a few years ago. It's a plug-and-play solution, and thank you very much. I've got an example here. When you're done drinking this PET bottle, in Europe, you can deposit it in a normal recycling stream, so in the plastic bin. Then at SUEZ and consortia, it will be sorted in the right way because the label is not covering the full package, as Vincent was describing. Then at the recycler, it splits into PET bottles, flakes sinking, and the label is floating. And then the label can be taken off from the recycling stream, and you get a very clean PET recycling granulate that can be used for bottle-to-bottle recycling. So we work together with external consortia as well to double-check if our theory is really working. And we have from Return Pack and Infinitum the most strict consortia in Europe for PET recycling. We have got their approval to call this Clean Flake, and it follows the clean away process. So also we have this on the booth today, so on the larger booth. So feel free to come and visit us and get some more information on this very interesting material. New today on the booth is that we also have Clean Flake Flecks. This is a solution for when the bottle has just been blown. When the bottle has just been blown, the bottle still deforms slightly. And then you want to have a label that accomplish this, this flexibility that is required in order to prevent wrinkling. So we have then an extension to our Clean Flake family. And I've got a short video to explain what Clean Flake is doing. So here we go. And I think I have to do this manually.
With world population growing to 8 billion people, natural resources have come to a limit. But the demand for plastics keeps rising, especially for PET bottles and thermoform containers. The good news, PET is 100% recyclable. However, standard PS and shrink labels limit recyclability. Leftovers from adhesive, ink, and face stock contaminate the flakes and prevent reuse for food packaging. Avery Dennison has developed the Clean Flake portfolio, an innovative solution to allow clean recyclability. Clean Flake adhesive technology separates cleanly during the recycling process. It comes with clear and white label material tailored to PET bottles or thermoform containers and fits all current printing techniques. The unique water-based adhesive sticks to the container to the very end of its life cycle. But in the recycling process, the caustic wash breaks the cohesive bond, allowing the labels to separate cleanly. No residual adhesive remains on the flakes, no contamination. Avery Dennison Clean Flake enables true bottle-to-bottle recycling. 100% recyclability makes the difference on the shelf and helps the planet, as it saves precious natural resources and reduces greenhouse gas emissions.
So thank you very much for your attention, and we're happy to take some questions at the moment.
Thank you, Jenny. Thank you, Vincent. Any questions from the audience?
Yeah, because now we can.
Hi. Hello. Good. Hi, I'm Alistair Hanlon from a company called Pragmatic. We're an RFID company. I wanted to ask about current labels today. Are any of the labels recycled at all, or are they all being floated off or floated down?
What we see is that typically only in PET recycling, there all the sleeves that are actually floating, basically all the floating material, also including the caps, will be shipped to a mixed polyolefin recycler. And there you basically are creating a blend of PE and PP with some other materials in between. And it's used for more thick wall materials, big plates, garden furniture, stuff like that. So we consider it downcycling. So it's not fully recycling. It's not near to virgin quality. Yeah. But for everything that's at the PE or PP recycler, it's discarded. Yeah.
Any more? Anyone?
Concerning the sleeves, Liam, I saw PET on a PET bottle is not recyclable, and I know the sleeve manufacturers are working on a solution with washable adhesive, things like that. Is that something they do in cooperation with companies like yours?
When you look at the current sorting steps at the recycler or at the reprocessor, you typically see that they try to get rid of lightweight material. It's lightweight, so it doesn't add a lot to their mass balance. And they know there's still a lot of material in there that they don't like. Also, all of the inks are in there, so if you want to have a clean, transparent or whitish recycled material, you want to get rid of that as much as possible. So the design should be to not hinder recycling, rather than it trying to be recyclable. Because I don't see the big changes at the recyclers at the moment that they would actually change their process to have them recycled as well. Yeah? Okay.
Last chance? Yeah.
Hi Vincent, very good presentation and thank you. You mentioned that PP and PE labels are allowed for PET recycling, but then would they have to fit also the same requirements as you mentioned for the adhesive, that it needs to be washable, so it's not just any PP or PE label?
Yeah. So the basic issues with size, glue, or adhesives and inks being used are still the same. Yeah. Yeah.
Any more? Or you're still busy?
So,
Any more
Vincent, I also
questions?
have a question to you. On one of your slides, you mentioned chemical recycling, and that is perceived to be sort of the holy grail for the future. It's sometimes mentioned as, oh, I can just throw in chemical recycling, any plastics, and then, ta-da, we get virgin material back.
Yeah.
From a technical point of view, I know that's not exactly the way to go, but what is your perception on chemical recycling?
If you look at chemical recycling, just as the current mechanical recyclers, also chemical recyclers are dedicatedly working on one type of material. So we have Ionica now having a first plant in the Netherlands on the depolymerization of PET. So if you put a PET bottle in there, like the one I've shown previously, with the LDPE wrap around it and the PE cap, actually, first we still have to do the sorting step because they want a high yield. So you cannot just throw every packaging in there. So the first step still needs to be done. So we need to be able to identify it as a PET bottle. And when it goes there, everything that's on there, which is not PET, will actually be discarded as well. Mm-hmm. They're only looking for the PET. For GPET, I told you GPET sleeves, it might be a solution. But at the moment, there's only one plant in the Netherlands taking in limited amounts of material. Great technology, by the way, but still needs to prove itself. And when this is expanded throughout Europe, and you really can do this at scale, then having GPET sleeves might be an option for PET bottles.